Right, good morning everyone. Hopefully you're all coffeed up and attentive, and the biscuits aren't just sugar rush from the biscuits isn't making you sleepy yet. I hope not. My name's Tom Fairbairn. I'm going to be talking this morning. Subject is tasty topics. This is a kind of use case based introduction to some of the more interesting things we've seen our customers been doing with the idea of topic routing and filtering. So I'm just going to briefly talk about PubSub. Hopefully we're all kind of well aware of what that is. I'm going to review that briefly. And then get straight into these use cases. The idea here, the idea behind this talk really is to just hopefully open your eyes to the kinds of things you can do with topic routing that maybe hadn't occurred to you. So just to give you some extra weapons in your toolbox when you're developing some distributed systems. Okay, quick word from the organisers. This is, oh dear, that looks awful. This is actually my first GOTO, and I'm speaking at my first GOTO. So feedback is important, so please go to the app and give me a rating. I'd love to know what you think of this talk. Hopefully you'll find it useful. Okay, it's kind of obligatory at these things to give, what's it doing that? To give you a quick introduction to me. So I started off life as a chip designer actually. So I was doing low power ICs, low power processor ICs. So there's a little bit of me in every single one of these. There you go. Moved to Singapore and ended up working in technical support, supporting customers in their production systems with Solace. And then moved back to the UK and moved into a kind of more system architecture kind of role, helping customers with their messaging problems, and of course that's where these experiences come from really. So that's me. Yeah, we have a booth outside. It's the one with the little noisy toy train coming around, which people seem to find kind of interesting, so please come and have a look at that. Okay, let's get into the meat then. Publish, subscribe. Can I have a quick show of hands who, if I say publish, subscribe to people, who knows exactly what I'm talking about? Okay, so few, some not hands. Okay, so what is publish, subscribe? So very simply at a conceptual level, we have things that are producing data, which we call publishers. And what the publishers do is they identify the data that they're sending by attaching a piece of metadata. And that metadata we call a topic. Now in a well-designed pub subsystem, that topic should describe the data rather than the application. Okay? And hopefully throughout this presentation you'll begin to see why. Now obviously there's no point sending out information unless somebody receives it. So our receivers are called subscribers. Now the reason they're called subscribers is that the subscribers identify what they're interested in receiving by applying a subscription, which is a set of matching topics that they'd like to receive information on. Now, the point with this is obviously in addition to it being distributed, depending on how you set things up, these could be global, these could be in the data center, but it's also decoupled. Your publisher is not aware of who is subscribing to his data, and he doesn't care. So the important point here is if the subscriber goes offline for some reason, that does not affect the publisher. Likewise, your subscribers are not aware of who's publishing. So the whole idea is you're decoupling who's sending from who's receiving. You can have multiple publishers on the same topic, and you can have multiple subscribers to the same topic. You can have none to many. None is obviously not particularly useful. Okay. So the idea of having many publishers and many subscribers is something you would call fan in and fan out, right? You might have something like a big data cluster that's ingressing a lot of information, and that's the only subscriber, whereas you might have lots of publishers publishing to that particular topic. Alternatively, you might have a single application that's, say, sending out a flash sale notification or something, and we'd call that fan out, because you're sending out to multiple subscribers. Now, typically in your kind of textbooks, when we talk about pub/sub, the idea of persistence, it doesn't really apply. So this is something typically where your sender and receiver need to be online. There's a good reason for that. If you're having to persist the information you're sending, you need to know how many consumers you have, and that breaks that decoupling model. But we have a way of dealing with that, which I'll talk about later. So yeah, the whole kind of focus of this then is that our subscribers register interest to a topic. There could be multiple topics. And the key here is how you manipulate that registration of interest, that subscription, to get the most out of your pub subsystem. And that's really what I'm going to be talking about today. So let's delve into topics a bit more then. So if there's one thing I'd like everybody to get from this talk today is that if you're going to be doing pub sub, having a topic being just a tag, just a string, means that you lose a whole lot of the power of publish subscribe. And these examples here are going to illustrate why that is. But if you think about it quickly, if a topic is a simple tag, it's just a string with no semantic meaning other than just the characters in the string, if your subscriber is having to listen to more than one thing, you have a little bit of a problem at your hands. What you could do, of course, is you could list everything that you want to listen to. So in our example here, we're talking about apple slices. So we might come up with a tag that says food apple slices. Right? Doesn't really matter how you do it. But the problem is if you then want to listen to something like ham slices, obviously you have to list them. Okay, all right, well, maybe if we format our tag, we could then do some kind of string search on it. So maybe we look right to the end and we look for slices in the name. Not quite so good that. If we use a hierarchical topic, which looks a little bit like a Linux directory structure, we can use wildcards with that, and we can select and pick out pieces of our topic hierarchy that we're interested in. So if we're interested in, if our application is interested in the type of food slices, we can just use wildcards, and then it becomes simply an exercise in manipulating the topic hierarchy and applying the wildcards as you need. So you can see there that having a topic hierarchy gives you more power. So who cares about this? Well, if you think about deploying that previous model here, if I have a new type of food, I don't know, pear slices, for instance, if I'm using a tag, if I have this list approach, I have to restructure my list, validate it, and then deploy that to all of my listeners. If I'm using my string search approach, well, I have to make sure that my tag matches my string searching algorithm. And that's important there because what I'm doing is I'm matching my tag to what my listener's string search algorithm is, right? It's not immediately obvious what you're doing there. Whereas if you're using this hierarchical structure here, as long as you keep to your hierarchical structure, any listener that's interested in slices will get any slices. And what's more, that's defined at the publisher time. So creating a new type of slices is as simple as just sending out, publishing that information. And that means it's a lot simpler. You have better consistency. So imagine you're using your tags and you're doing string searching. Well, everybody does string searching in a different way, probably. I'm sure there's libraries. Everybody will have their favorite library. They'll do it differently. Supposing you're using different languages. Again, you're likely to get different string searching implementations. And the last point here, which is kind of more important if you're talking about more Internet of Things type things, when you've got low power sensors and you're trying to optimize the use of your last mile bandwidth, is that when you use this kind of topic filtering here, it is up to the messaging system to make sure that it is only sending you the data that you're interested in. Whereas if you're filtering at the client, obviously you take all of the data in and then throw away the data you're not interested in. So, hopefully the topic is not a tag idea. Kind of convinced now. All right, let's dive into a use case then. Some of these use cases are probably kind of obvious when you first look at them. Some of them are a little more esoteric. So this one's probably fairly obvious. Some of you may even already be doing this. But let's imagine we're working at our funky startup, right? And we've come up with a data format for our employee database. So here I'm using JSON, and I'm a funky startup. It's all a bit loose, It's just me, and I'm a magician, and there's my mobile number if you need to contact me, all right? It's all great, we're all funky, we're all happy. But guess what? Our startup's been really successful, and now we've been bought by some bigger corporation, and there's HR people involved, and they're a bit more strict, and they want to know who you report to and who reports to you. Well, that's fine, all right? You just cut over to the new data format and everybody's happy. But then you get a ring on the phone from your HR people who say, you know what? We haven't been able to migrate our HR reporting system fully over yet. So we actually need to send data in both formats until we completely migrate those systems. That's a bit of a problem, because if you're trying to parse this JSON, right, you don't want to send the wrong data to an application that's expecting a different format. You could, of course, do a load of coding and exception handling and stuff, but maybe there's an easier way. All right, well, hopefully we're using our continuous integration, continuous deployment pipeline, and hopefully we can start using some of the hooks in that pipeline there to help us. So what we can do here is we can use our description of our data format here, and if we tag that with a version number, we can have a version control system emit that tag on build. And then we can use that tag during the build process. And it looks a bit like this. So what we do is we parse our JSON there, and we tag the different JSON formats. Then, when we want to send or receive that data, we export that tag name, and when we build our code, we use that tag name. And then, in our code, we don't have to worry about those different versions, because it's all been done for us in that tag name up there. By the very nature of the fact that we've built this with a different version of the data format, that means we're going to be sending it to a different topic, and we're going to be receiving on a different topic. And now our problem of, I've got two data formats, I need them both to be running at the same time, I don't want them crossing streams, if you want the Ghostbuster analogy, is solved simply by using the build process. Because what we've got now is two topics, and by the nature of the build process, our data format applies to the topic that it applies to. Job done. What's more, it's very difficult to break that, right? You can't accidentally send it to the wrong topic, and you can't accidentally subscribe to the wrong topic too. So that's quite neat. That's quite a simple example. Is that kind of clear? Makes sense? Anybody got that kind of problem that they need to solve? Anybody? No? Okay, all right. I'm going to move on to a different case study now. Over at our booth, we can actually show a demonstration of this. If I've got time at the end, I'll try and bring up a demo too. So this is moving on to that Internet of Things idea. This is around kind of geolocation, geofiltering, right? So imagine you're waiting for a delivery and you live, for some reason, just down the road from the Thameslink station. Wouldn't it be nice to be able to pick up the nearest delivery vehicle that's near you? Imagine you're waiting for a bus. Wouldn't it be nice to know where the nearest buses are so you can plan your bus route? So this applies to anywhere where you have a need to be updated about the geographical location of things. Okay, so one of the key things about these topics is that they are just a property of a message. These are dynamic entities associated with the message. They're not something that is an administered or static object, right? The power of that is that you can change the topic whenever you like. You can decide on the topic when you publish the message. So let's imagine then that we put the location of our thing of interest, in this case a vehicle, into the topic. Okay, so every time the vehicle's location is updated, it publishes that information and it updates the topic with its new location. Okay, so if we look back to our hierarchical topic filtering examples, what we can do, for instance, is if we need to know where a particular vehicle is, that's easy, right? We just wildcard the location. We're not interested in the location. And that way, any update that that vehicle produces will be sent to us because of our subscription. Okay, so far so easy. But there's a bit more we can do with this. So these topics are strings, which makes kind of numerical comparisons a little difficult, but with a bit of imagination, we can get over that. Let's start thinking about where we can place wildcards in strings. If we can sub-wildcard part of a string, we can start doing some quite powerful things. So here, what I've done is I've wildcarded the last significant digit of my location. So that obviously means I'll get, for instance, for the latitude there, I'll get 51.520150 to 520159. And of course that maps to a specific location. If I do that on the latitude and the longitude, what I end up with is this rectangle here that's about a couple of meters wide by about 3 or 4 meters long. So that's interesting. Just by applying a subscription wildcard, I'm now matching a particular area of the globe. Okay, we're getting somewhere now. So, simply by moving my wildcard up and down the significant digits, I can expand and shrink the area that I'm matching with my subscription, right? So if I go to the third significant digit here, I get a nice big kind of half mile, half kilometer maybe, by mile wide rectangle. Okay, that's kind of interesting. So for those of us that know Fourier transform theory, you know that essentially any curve can be approximated by any square. That's how your MP3 player works. And we can apply that here. Simply by selectively refining the rectangles that we're picking, we can approximate any shape. And that selective approximation is done by simply adding more and more restrictive subscriptions here. So you're kind of moving up and down the significant digits. And that really is it. It's quite simple in a way. It's probably not immediately obvious. But by doing that, you can match down to, if you want to, almost meter accuracy, any location. And the point of this, of course, is that as your vehicles, planes, RFID tags, whatever, are moving around, you are only getting the data from those tags that you're interested in. That's quite powerful. So if we take this to the extreme, if you want to match a circle, for instance, you can do it with a reasonable degree of accuracy. Now, this is a use case thing. You're developers. I'm not going to try and hide how you do this from you. Actually, the algorithm's pretty simple. What you do is pick any level of significant digits and create four matching rectangles. Okay, so for the Earth, that's eastern and northern and southern hemispheres, right? 4 rectangles covering all of those. You see if you match your polygon of interest, and you throw away those that don't. And depending on where you are, you get to something like this. And then what you do is you simply hop down the next level of significant digits and iterate. And you just do that until you get to the desired level of accuracy. Really quite a simple algorithm, actually. It's quite nice. And you end up with this kind of structure here, where depending on the level of accuracy you desired, you change the number of matching rectangles. And those rectangles, remember, are simply a wildcarded subscription that you're applying. That's it. And now you've got streaming, geographical-based matching. All you've done is used a dynamic topic, which is just a property of whatever's sending that information, And just by moving a wildcard subscription up and down your location string, you can match anything anywhere in the world. It's quite nice, quite powerful. Actually, there's an extra little hint to this, which I quite like. So how are you going to deploy this algorithm, right? So that's selecting these subscriptions. So what the first thought that might occur to you is the application that's doing this matching, it needs to generate the subscriptions, so I'll deploy a library, right? And the application just picks up a library, makes an API call. You get back a bunch of subscriptions that you need to apply, and you do that subscribing. But there's a different way you can do that. In Solace's pub subsystem, what you can do is have an application apply a subscription on behalf of another application. Now it gets interesting, because what you can do is you can do all of that subscription generation logic in this subscription application here. And that's really quite nice, because then your filtering application, all it needs to do is send a message saying, I want this polygon, or I want this circle. That flows as a message. The subscription application picks up that message, calculates the subscriptions that are needed, and then applies them on behalf of your filtering application. So all your filtering application has done, in fact, is just made a call, effectively. And all of a sudden, all that data that it's interested in starts streaming towards it. And that's really quite powerful, because you don't have to have any of that logic that generates those subscriptions in the application at all. All it needs to do is worry about what it's going to do with the data when it gets it, and making the right call to get that data. So if you need to update your subscription algorithm, well, you only have to update it there. You don't have to deploy that across all your filtering algorithms. It's really quite powerful. I like that. And we'll come back to that. There's some other ways you can use this on behalf of subscription model. All right. Okay. Good. Let's talk about replay. So this is kind of I was going to say topic there, a subject that the microservices community are quite interested in. So with microservices, you've got this idea of polyglot persistence, right? You're wanting to save information for your microservice locally in the best format that you possibly can. So the question there becomes, what about state? How do I save state? So do you want to save that locally? Then you have distributed state stores all over the place. So maybe that's not a great idea. So one of the ideas that's come about is this idea of replaying a state of the world stream. So if my microservice fails, rather than having to start up and read some kind of database, instead, why don't I just replay the event stream that got me to that state in the first place, right? So how are we going to do this? Well, the thing is here, if we're going to keep a copy of our state of the world, we need to be able to persist that state of the world, right? So if you remember at the start, I talked about publish, subscribe doesn't really have the idea of persistence. Well, what if we take a typical message queue, and what if we enable that queue to subscribe? What we can do then is have a single queue that's holding all of the information that your microservice has received, and you can attract all of those topics into the queue. And what that means is that queue will hold the full stream of events bound for that microservice. And now we have our streaming replay of the world, because all we've got to do is read that queue out, and I know exactly what my state should be. Now, what you could do is just consume all of those messages off that queue. Well, that's great, but what happens if you fail again? So the key there is to do something called queue browsing, for those of us who used to use JMS. What that means is you replay the messages off the queue without consuming them. So they're still on that queue. And what that means is then you've got a queue that's always got your stream of events in it, always ready for you to replay to recreate your state. Okay, yeah, that's great, but what if I've got my system up for, years and years and years? That queue's going to fill up, right? Well, yeah, sure. What you can do, of course, is apply a time to live. to that queue. And then that way, say you have a regular day operation, for instance, you can throw away all your state on the queue at the end of the day. It may be that you know that there's a periodic snapshotting function going on there, some kind of cache that can squirt out a instance of state to you, and you just apply your TTL to apply before that snap of cache. There's something else you can do here too. Being able to recover is one thing, but if you're sending out some kind of transaction or a persisted message, it's kind of handy to know whether you were actually successful in sending that message before you died. So what you do for that is you set up this thing called a last value queue. That's a queue that can only hold one message, and it only ever holds the last message that you sent. And great. Come up on startup, read my stream of events, recreate my internal state, look at what I'm expecting to send, look at my last value queue, say that was the last message I sent, and I'm ready to start processing from where I left off. It's quite neat. You can manipulate these subscriptions on your queue. These are dynamic too. They can be wildcarded. There can be more than one of them. So you can pick out just the information that you're interested in as far as state goes. So maybe there's control and configuration events coming towards you, and actually to replay your state, you're going to get that from your polyglot database, so you don't care about those. Great. You just subscribe to only your control and config streams. Okay. Replay. Let's talk about authorization. One of the weaknesses traditionally of a pub sub system, right, is that you're sending this data out, and the point of authorization is the point at which a client can connect to your pub sub fabric. Now, you can apply access control lists that restrict the topics that that client can receive. It's kind of half the answer, right? What if that level of authorization needs to be dynamic? It may be you're authorized for a short amount of time. It may be that, for instance, you've got individual users attaching to the message bus, and you want to make sure that user A is only validated for user A's data. Pretty messy if you have to generate an ACL list for that. Can we do it dynamically? Yeah. Well, if you remember from the geolocation example, we can have a subscription app that decides what all of the other applications that are connecting to the bus can receive. And he can do all of the logic deciding what the other applications are allowed to receive. The powerful thing about that is that your subscribing application is not aware of what the topic structure looks like. It never sees it. It never has to subscribe. All it knows is that it needs to make a request for some information. And in that way, there's no chance that he can subscribe to other topics, because he's not allowed to. Your subscription app is the only person that's allowed to give him any subscriptions. And so, for instance, say you've got a retail app and you're buying some things, and you have an account balance, or you're sending payments. By using this method, you can make all of those channels private, and you can do it dynamically. Could be, for instance, that you're wanting to send out a flash notification. Hey, there's a sale. I'm going to give this item 10% off only to loyal and good customers. How do you do that? Well, you can't do it through an access control list. He can go and look off at your marketing database and decide who is valid for that offer at runtime. So it's quite a nice way of doing authorization. So, how that works, my subscribing app, whatever that is, sends in a request. I want my account balance, for instance. My subscription app calculates what the subscriptions are, and then just applies those subscriptions on behalf of them. So just to make that point again, that means that any app can't subscribe to anything that he's not entitled to. Okay. Coming up to the last one now. We're on the home stretch. All right, monitoring. So when you've got this pub sub kind of system here, you might be wanting to monitor the activity going on. You might want a dashboard. How many people are requesting account updates? is my account system able to cope with that kind of load? I want to do some capacity planning maybe. So who's talking the loudest? Who's sucking up all of the data? Could be your data lake, for instance, that's listening to absolutely everything. That's super easy with PubSub, by the way. If you want a data lake that listens to everything, you just apply a global wildcard subscription, right? Job done. Okay, so which of my applications is really busy and falling behind in the message flow? This is my favorite. Who's stuck? So how are you going to gather this from your PubSub system? Well, you could be sending out heartbeats, for instance, and that's obviously something you could do. The power there is that you can send out your heartbeats PubSub, and then your heartbeat application just leads to listen to the heartbeat topic. Taking that a bit further, why don't we write our monitoring app? That's probably using some kind of API to query the state of the PubSub system, right? So do you have any queues overflowing? Who's sending the most messages? Is there a client that's behind in the message flow? That kind of thing. He can use that API to gather all of that information, but then he can, of course, publish it, publish, subscribe. And then anything can listen to the state of the message bus. So you can just plug in your management dashboard. It's going to flash up an alert and say, hey, look, he's really busy, or he's stuck like that panda, right? What about maybe your operations team likes to go home at the weekend sometimes? Surely not. Well, it'd be nice if they didn't have to fire up a laptop to get an alert, right? But if we could push stuff out to mobile devices using PubSub, it's quite nice. And here's what it looks like. Yeah, so here's what it looks like attached to our London lab servers, for instance. So you've got how much data is flowing out, how much data is coming in, what are your message rates like, are you up, active and ready and willing to go, how many connections do you have? And that's just a plain Grafana dashboard there. We're simply putting all these statistics, we're subscribing to the message bus, pulling all the statistics off and putting them in InfluxDB. It's kind of a morning job to build a dashboard for that. It's kind of neat. Well, that's it for me, really. This being a developer conference, there has to be a code snippet, right? So here's how it looks. All right? If your topic is not a simple tag, then you get all these things like doing this kind of geographical data filtering using topics. You get very easy ways of separating out different versions of the same data, different formats of the same data. You can do things like replay really quite easily. That's it, that's all I've really got. Thanks for attending, I hope you found that useful. There are many other use cases. If you're interested, please come and see us on our stand. Remember to rate this session. I'd be interested to hear whether you thought it was useful or not. Thank you very much. Okay, are there any questions? I was just about to say, surely it can't have been that clear that it was immediately obvious. Yes, sir.
Just wondering what the sort of the latencies are for all these dynamic subscriptions that you have. You know, creating 100 subscriptions, dropping 100 other 100 subscriptions.
Yep.
Can you do that every couple of seconds?
Okay. So just to reiterate the question, what's the penalty for applying and removing these subscriptions? So you remember I said that as far as the publishing topic goes, that's just a property of the message. So for the publisher, it doesn't count, right? Doesn't. Okay. For the message broker, actually doing these kind of subscriptions isn't that painful. So one of the tests we run is we'll apply 1 million subscriptions and tear them down, and that will happen in typically less than a second. So for any message broker, essentially what you're doing is making up a hash table. Right, it's just you turn your wildcard into a hash match. stick it in a big table. So kind of algorithmically, it's not that complicated at all. It's not that difficult at all. Yeah, good question. Thank you. Yes?
With your subscriber app, isn't it like a central point of failure? Like
Yep.
down and nothing
Yep.
gets subscribed?
Okay, so yeah, so that's a very good point. So we are in this kind of example here, right? No, not that example. We are in this kind of example, yeah? So yes, so what happens if my subscription app falls over, right? Well, if my application connects at that point, he's not going to get the subscriptions of interest. He's still live, he's just not receiving any data. So, you could flash up a warning saying, there's a problem. But this is publish subscribe, right? So the first thing you can do is you can stripe across these subscription apps here. So actually the request topic can be striped across lots of different topics to give you load balancing. But for failures there, what you would do is simply scale those subscription applications out horizontally. And you can either use something like messaging to elect which is the primary, or actually, in our particular feature, we can say, I'm publishing a message, but only want it to delivered to one subscriber. The first one that connects will then get those messages. If he dies, the next one to connect will then get those messages. So yeah, good question. Kind of easier to. Yep.
Which pubs or buses would you recommend for a polyglot environment?
The answer to that one is easy. That would be the Solid Systems pub sub bus. Hands up, who's surprised by my answer to that one? Yeah, I'm from a vendor, right? So I have to plug my own solution. Kafka, is a great solution in this space. But, kind of the point of this presentation here, that it does have some weaknesses. And the whole topic subscription, topic selection part of Kafka is a little weak on that side. And these are some of the examples of some of the things you can do with a more sophisticated publish-subscribe system. Yeah. Any other questions?
So how does the pops up load when that app in this scenario? How does it? What does the app say to say?
Yep. So how does that exchange? Okay. So the question is, how does the application that's connecting that wants to ask for a subscription, how does it know what to do? Okay. So the flow is like this. You will have a topic or topics, and we would call them a well-known topic. What does that mean? It just means it's something basically you hard code in there that says when you want to request your subscriptions, send a message to this topic. Okay, so it would be something like subscriptions authorization, something like that. You then send a request. So in terms of your message types, you've got pub sub, you've got request reply, you've got persistent. So in this case, we'd use a request reply style of pattern. And you'll send a request saying, request, I don't know, it could be the polygon in the geofiltering example. And the message data will be that polygon data. And then it's up to your subscription app to subscribe to the right topic, which it's a well-known topic, so hopefully it does know, right? So then what happens is your subscription app then replies directly to whoever's done the request and just says, yes, you're authorized, or no, go away, you're trying to hack me. And that's all that happens. What the subscription app does is as soon as he makes that request, he then knows his, in our terms, he knows his client ID. So he applies a subscription, and one of the parameters to the subscription call is client ID. And that's it. Then what he's done is he's basically inserted a subscription up here on his behalf. Good, thank you. Any other questions? No? Okay. If you do have other questions, feel free to use the app or come and see us at booth 9. We're very friendly people and we have a toy train, so we're worth seeing. All right, thanks guys.